Alright, so we're skipping ahead here. We're going to go to chapter 7 and then we'll come back to chapter 5. And I do chapter 7 before chapter 5 because I want to do all the derivative stuff first. And chapter 5 is antiderivative. So that's the last thing I do in the semester. Alright, so we are in chapter 7. And so what chapter 7 is, it's functions on several variables, meaning our function is going to have more than one. Up to this point, we've only had one variable type functions. But everything that, or most everything, that we did with one variable, we're going to do with two variables, to an extent. Alright? Now there are limitations to it, but we will be doing similar stuff. Alright? And so just to, again, in an Algebra 2 class, you should have done multivariable functions, but just to remind you what multivariable functions are. Alright, so by definition, a function of two variables. Alright, so there's an x, y, there's two independent variables, an x and a y, again, is just what we're going to call them. So again, those would be our inputs. Then the function is the rule that assigns to each pair. Alright, so there's two values, there's an x value and a y value, and that would be the domain. Alright, so instead of one value, there's two. When you plug that value into the function, you apply the rules to it, add, subtract, multiply, divide. You should get exactly one real number out. That's what makes it a function. And that's the dependent variable. Usually we label it z. It's the output of the function. Right? And if you were to graph these, these would be graphed in 3 dimensions. You'd have an x-axis, a y-axis, and a z. And again, we're not going to graph them. We are just going to deal with them and do some applications of them. Alright, so most of our applications are going to be denoted some function. So the generic one would be f of x and y, x comma y. And so we're plugging in x and y into our function. We're going to apply some rules, and then we should have got a single numerical value, which we're going to now label z. So a simple example would be this function here. Alright, so this function is f of x and y is the function where I take 2 times x times y, subtract the natural log of x, add to it 5 times y squared. When I plug my x and y values into that, I should get a z value out. And so I'm going to just do a couple of simple examples where we'll evaluate. Evaluating means solve for. Alright, so for example, if my function f of xy was just a simple function 4x squared minus 2xy plus 3y squared, so, and we want to find f of 2 comma negative 1. And so what we want to solve for is the z. Our x value is 2, our y value is negative 1. What we're going to get out is our z value. And so it's just plug it in carefully. What's going to be harder about these functions is there's a whole bunch of different, it's going to be a long expression of x and y terms. And so just make sure you're careful when you, again, plug it in. The biggest thing is make sure you're careful when you plug in your 2 for x and your negative 1 in for y. So we're going to take 4 times 2 squared minus 2 times 2 times a negative 1 plus 3 and then negative 1 squared. And so the biggest thing is make sure you're careful of the negative. Remember, it's squared, so it should come out positive 1. Alright. Alright, it comes out 23. Alright, so the function value, or the z value, f of 2 comma negative 1 is 3. And again, it would be an order triple if we wrote it as a pair. I'm not going to, since we're not going to graph it. But it means when I plug 2 and negative 1 into this function, 2 for x specifically, negative 1 for y. Oops, and I wrote 3, it should be 23. My function value is a unique number, and it's only 1, right? I get one single value out, 23. Alright, let's do another example. Alright, so again, not that hard. It's just more than one value we're going to plug in. And you could have 3 or 4 values. We're only ever going to do 2 variable functions. But I could have a function with 3 variables, 5 variables, 6 variables, if I wanted to. Let's, instead of doing f, let's do c. Alright, c of p and q. Alright, so it'd be the natural log of p minus q. Natural log of p times q minus 4e to the p. Alright, and so I want to find this function at the values 1, 3. Alright, so 1 is the p value, 3 is the q value. So I plug those in and just make sure you're careful. So it's the natural log of 1 times 3 minus 4e to the 1, right, because it's the p value 1. And then you just solve that on your calculator. Alright, so you'll plug in the natural log of 3. Alright, so it's exactly the natural log of 3 minus 4e. And then you type natural log of 3 into the calculator and subtract 4e. And it comes out, if I round a couple decimal places, negative 977. And that's what's unique, right? If I plug negative 1, 3 into this function, it comes out that unique value. We are going to eventually do applications. Specifically, we're going to optimize, just like we did with one variable functions. One of the first applications we looked at was optimization. We're going to do marginal analysis and optimization. Those are the two types of application type problems we're going to solve. Alright, we're not going to do any of the graphing stuff because, again, it's hard to graph three-dimensional objects in a two-dimensional shape. Alright, so, but we are going to do the functions of marginal analysis and optimization. Alright, so in order to get to those, sometimes we have to set it up, and we're going to stick to most of the time our applications just like our one variable cases. For our two variables, we are going to stick mainly to revenue, cost, and profit. Alright, so we're going to do marginal analysis on revenue, cost, and profit, and we're going to maximize and minimize maximize revenue and profit, minimize cost. And again, we are only going to look at two variable cases, but the idea would be extended to if I had more than two variables, but we're just going to do two variables. Revenue is still price times quantity. Right, the difference here is you'll have two prices and two quantities, and they could be single numerical values or they could be two functions that represent my price. Profit is still revenue minus cost. The hardest thing about this is when we subtract revenue and cost, you remember you can only add and subtract like terms, right? Collecting like terms. So you can only add function parts, terms, that have the same variable parts, meaning if it has a single x value, you can only add it to another value that has a single x. Or if it has x times y, right? You can only add a value. The variable part is x and y, all right? So again, you have to have like variable parts in order to add and subtract the terms. All right, so I'm going to do a simple example. All right, so this first example is going to be a revenue and then get to a profit. All right, suppose we have a concert. All right, they have two kinds of souvenir t-shirts. All right, the first kind they sell for a price of $18 per shirt. The second souvenir shirt sells for a little bit higher price, maybe has more graphics, at $25 per shirt. So the revenue, and you got to keep in mind everything's in thousands of dollars and thousands of t-shirts. All right, so revenue is price times quantity. So the first one, which represents X thousands of the first type, sells for $18. So this one's just a simple price. 18 is the set price. If we sell X of them, right, X of those 18, right, because that's what the X represents, that's the revenue from the first type of t-shirt. And then the second one, we're going to sell Y of those, right? Y t-shirt represents the $25 t-shirt, and so the revenue generated from that is the price of 25 times Y. So those are just set prices, linear prices. And so there's my revenue equation, the revenue generated from selling the two different types of t-shirts. Again, keep in mind everything is in thousands when I go to write my final answer. All right, so the total cost is in thousands of dollars when we make X of this first type and Y of the second type. The cost is given by that equation, so that complex equation, again in thousands of dollars. Find the total profit in terms of thousands of dollars for producing and selling each of our different types of shirt. Alright, so remember, profit is revenue minus cost. Right? Just like in the one variable case, it's just a little more complex because we got a little more going on. Alright, so the revenue is 18x plus 25y minus the cost. Put parentheses, I have to distribute that negative. So the cost function is 4x squared minus 6xy plus 3y squared plus 20x plus 19y minus 12, and I gotta make sure I'm careful. This is where if I'm going to lose a negative, I do. Alright, so the big important thing here is make sure you put parentheses because I'm going to have to distribute that negative before I can collect my like terms. I forgot my y there. 25y. And so everything in the cost function should have the opposite sign than the original. So if it was positive in the original, it should be negative. If it was negative in the original, it should be positive. So I get a negative 4x squared plus a 6x times y minus a 3y squared minus a 20x minus 19y plus 12. All right, so step 1, careful distributing your negative. And then the last step, collect like terms. All right, and so the only like terms I have are the x terms and the y terms, right? Everything else is different. I can only add x terms to x terms, y terms to y term. Everything else has a different variable part, right? So those are the only two that are like, that I can add. All right, so when I simplify the profit equation, I'm going to write them in order. So I typically do, so I'm going to write down the square and the mixed terms first. So negative 4x squared minus 3y squared plus 6xy. Now I'm going to add my x term, so I get negative 18x, positive 18x minus 20y, so I'm going to get a negative 2x, 25y minus 19y, so positive 6y, and then that constant 12 at the end. Alright, so there is my very carefully written profit function. And so again, the biggest thing about this one is it's not that much more complex to what we did before. There's just a lot more moving parts. Alright, so you have to be careful with, again, it'd really be easy to miss a negative. It'd be really easy to miss adding something together, add something together that doesn't actually add together. Alright, that's as simplified as it gets. Alright, so leave it like that. There is my profit function, which eventually we're going to optimize or do marginal analysis on. Alright, right now though, this is just again, introducing you to multivariable functions. And so we're just going to find the profit at 2, 3. Right, so this is evaluate, find, and then explain what it means in terms of the application, right? Whenever we do applications, you should always give your answer in context, meaning numbers have meaning in context. Alright, but first find it, then we'll go through explain it. Alright, so again, I'm going to plug my values into this expression. So make sure careful, 2 goes in for x, so it's going to be negative 4 times 2 squared, minus 3 times 3 squared, plus 6 times 2 times 3, minus 2 times 2, plus 6 times 3, and then add a 12 at the end. Alright, type it out carefully, because again, there's just a lot of numbers, so make sure you're very careful when you type it on the calculator. It's really easy. If I'm going to make a mistake, again, a lot of times I'll mistype something in the calculator. So a good rule of thumb is always do it twice. Alright, I believe it should come out 19, so there is the profit at 2 and 3, and then explain what it means. Remember, x is 1,000, y is 1,000, and profit is 1,000, so that's significant. 19 doesn't represent 19. 2 doesn't represent 2. Alright, so if they sell 200 of the $18 t-shirt and 3,000 of the $25 t-shirts, they gain 19,000 in profit. Alright, you could write out the word 1,000 too if you wanted to. I think it's always easier just to write out the number, right? 2,000. But you could write out the word 2,000 if you wanted to, or the word 19,000. Alright, so that's the interpret part, right? That's what they all mean in context. Alright, so that's 7.1. Again, it's a brief review. If you want to get a slightly more detailed review, you can go look at the book on Connect and look at some of the skills problems there. Alright, but I'm going to stop there. We're going to start into 7.2 on the next set of notes, which will be the derivative part, the calculus. Alright, so that's what the next set of notes is going to be. Alright, I'm going to stop there.